Hello, students, and welcome. Today we're going to tackle a foundational topic in quantitative aptitude, the number system. We'll clear up all the basics and then learn some amazing tricks that are going to save you a ton of time.
You know that feeling in exams when you see those super long calculations? It's easy to feel like they're just going to eat up all your time, right?
Well, don't you worry. In this explainer, we're going to learn some magic tricks that'll help you solve even the toughest questions in just seconds. So let's get started.
But before we get to the tricks, it's really important to have our basics down. So first up, let's meet the family of numbers. Okay, so the head of this family, that would be the integers. This includes all the negative and positive whole numbers, like -2, -1, then 1, 2, 3, and so on. The key thing to remember here is no decimals allowed.
Now, if we take just the positive integers and add one special member to the group, the number 0, what we get are whole numbers. Simple, right? Everything from 0 all the way to infinity. And if we take those whole numbers and just remove 0, we're left with natural numbers. These are the numbers we all use for counting: 1, 2, 3, 4. And of course, these can be broken down further into odd and even numbers.
All right, let's meet two very special members of this family. These are the ones you'll see pop up in exams all the time: prime and composite numbers. Understanding the difference between these two is absolutely crucial. Prime numbers are the ones that have exactly two factors, just 1 and the number itself. Think of the number 7. On the other hand, composite numbers have more than two factors. For example, the number 6 has factors of 1, 2, 3, and 6. Now, these facts are super important because they often come up as direct questions in exams. Always remember that the smallest prime number is 2, and between 1 and 100, there are a total of 25 prime numbers. You'll definitely want to make a note of that.
Okay, let's look at two more special categories you should know about: coprime and twin prime numbers.
Coprime numbers are any pair of numbers whose highest common factor, or HCF, is 1. What's interesting is that the numbers themselves don't have to be prime, like 8 and 9. They have nothing in common besides the number 1.
And then we have twin primes. These are a pair of prime numbers that have a difference of exactly 2. So for this one, there are two conditions that must be met. First, both numbers have to be prime. And second, their difference has to be 2. Okay, so are the basics clear? Good. Now it's time for that magic trick you've been waiting for. This is the magic of the unit digit. And trust me, it's going to save you so much time.
When you see a huge addition problem like this, don't panic. All you have to do is add the last digit, the unit digit of each number. So here, that's 4 plus 9 plus 1 plus 4, which equals 18. That means the unit digit of our final answer is going to be 8. See? Simple.
And guess what? The exact same trick works for multiplication. We only need to multiply the unit digits. Let's walk through it. 9 times 8 is 72, so our unit digit is 2. Then we take that 2 and multiply it by the next unit digit, 7, which gives us 14. So our new unit digit is 4. Finally, we take that 4 and multiply it by the last unit digit, 9, and we get 36. This means the unit digit of the final answer will be 6.
Here's a fantastic shortcut for you. If you have a multiplication series that includes a number ending in 5 and another number that ends in an even digit, so 2, 4, 6, 8, or 0, you don't have to calculate anything at all. The unit digit of the final answer will always be 0.
All right, let's take this concept to the next level. Now we're going to learn how to find the unit digit of numbers with huge powers, and do it in seconds. There are a few rules for this, and today we're going to start with the very first and easiest rule. This is what we call the no change rule. There are 4 very special numbers to remember: 0, 1, 5, and 6. If a number's unit digit is one of these 4, then it doesn't matter what power you raise it to, the unit digit will always stay the same. For example, take 9870. Raise it to any power you want, the unit digit will still be 0. Similarly, the unit digit of 9871 will always be 1. The exact same rule applies for numbers ending in 5 and 6. This rule can be a massive time saver for you. So, let's do a quick recap of everything we've learned today. We started by understanding the family of numbers. We cleared up the concept of prime numbers, we learned the unit digit trick for addition and multiplication, and we discovered the no change rule for powers. And now it's your turn. Here's a practice question for you.
What's the unit digit of this calculation? Use the tricks we learned today and be sure to let me know your answer down in the comments.
If you enjoyed this explainer and learned something new, please hit that like button, leave a comment with your feedback, and make sure to share this with any friends who are also preparing for competitive exams.
And for more helpful explainers just like this one, don't forget to subscribe to the channel. That way you'll get all of our updates right on time.
For even more practice, go ahead and join our Telegram channel. The link is in the description. And hey, if there's a specific topic you'd like me to cover in the next explainer, definitely let me know in the comments. Thanks for learning with me today.